Hey everyone, my name is Achut Kadia and this is my midterm teaching video. In this video, I'm gonna talk you through all the major concepts that we learned in this course so far, and I'll try to explain them in a way that any CS student can follow along, even if they have never done any sort of web development before. So, to make things concrete, I will be referencing two projects that I built during this course. The first one is my personal homepage, which is a multi-page portfolio website built with using HTML, CSS, and JavaScript. It's deployed on GitHub pages. The second one is called SkillSwap, which is a full stack web application where students can post skills they want to teach and find other students to learn from it. It uses Node.js, Express, and MongoDB on the backend and is deployed on Vercel. So here is how the video is structured. First, I'll show you a concept map on how everything fits together. Then I will do a quick overview of each technology we learn, and after that I will do a deep dive into REST APIs and trace how data flows through a full stack app. And finally, I will do a live coding demo where I add a brand new endpoint to the skills web. So let's get into it. Okay, so here's the big picture of everything we covered in the course so far. Right in the center, we have the REST API. Before I go any further, I think I should explain what this means. So REST stands for representational state transfer. It basically sets a rule for how front end and back end should communicate over internet. The idea is simple. The front end sends a request using standard HTTP methods like get, post, put, or delete. The backend processes it and sends back the data, usually as a JSON format. The REST in a nutshell. This is REST in a nutshell. I will go much deeper on this later, uh, but for now, the REST API is what uh, holds all of these other bubbles together. So let me walk you through each one of them. So starting up here, we have the HTML and CSS. This is the foundation. HTML gives you your page, its structure, and CSS makes it look good. Both of my projects use this. Next, we have JavaScript and DOM manipulation. This is what makes web page interactive. When you click on a button or type in anything in search bar, JavaScript handles that. Moving down, we have Node.js over here. This is what happens. This is what like make like lets us run JavaScript on the server instead of just in the browser. So before Node.js, like I think you used to learn a complete different language like Python or Java for the server side. Now you can use JavaScript everywhere. So then we have Express, which is a framework that sits on top of Node.js. It makes it easy to set up routes and handle incoming requests. Think of it as a controller for your server. And then we have MongoDB, which is our database. This is where all the data lives. You like user posts, inquiries, everything gets stored here as a JSON-like document. And then finally we have deployment. This is how we take our apps running from our laptop to being live on internet for anyone to access. So my personal homepage was deployed using GitHub pages, and my the other project too called SkillsWeb was deployed on Vercel, which can handle both static files and our Express server as a serverless function. So notice how the color coding goes here. The pink area shows the personal homepage, like all the bubbles that was covered by the personal homepage, and everything else like which is inside the blue bubble was covered by SkillsWeb. Okay, so let us start with HTML. HTML is a skeleton of every page. It defines the structure and the content in it. One of the key things we learned is semantic HTML. Instead of putting everything inside generic div tags, we use tags that actually describe what happens, like what content is in it. For example, nav for navigation, or or may um, or like main for main content, and article for individual pieces of content like a blog post or a card. We also learned about meta tags in the head section, the viewport meta tag that's what makes your site work properly on mobile devices. The description and author tags help with SEO, so search engines can understand what's going on your page. Now, here's something interesting about my two projects. My personal homepage is a multi-page website. It has three separate HTML files: index.html, about.html, and projects.html. So when you click a link, the nav bar browser loads a completely new HTML file. But in SquareSwap, it takes a different approach over here. It just has one HTML file with an empty main tag. All the contents are generated in JavaScript. So when you navigate around the app, the JavaScript swaps out what is inside the main tag. This is closer to how modern application works. So next up we have CSS. So CSS control how everything looks on a page. The two big layout systems we learned are Flexbox and CSS Grid. The Flexbox is great for laying things out in one direction. I use it for my navbar, hero section, and button groups. You set display button on container and the children line up in row or column. CSS Grid is for two-dimensional layout. Here is a great example from my project. This is one line of code that creates responsive card grids. So repeat auto fit min max 300 pixel. What this does is it says make as many columns as you can fit, each at least 300 pixel wide, and if there is extra space, stretch that out evenly. The beautiful thing is the responsiveness. Without even writing a media query, the code automatically wraps to fewer columns on smaller screens. But sometimes you do need media queries for bigger layout changes. In my personal home page, the hero section is a row on desktop with the image on left, text on right. But on my mobile, I just make sure it stacks vertically. I also want to mention modular CSS and SquareSwap. Instead of one giant CSS file, I split it into 7 separate files: one for nav, one for postcards, and one for models, and so on. This makes the code much more easier to maintain. And now JavaScript. So this is where things get really interesting and powerful. So we learn ESX modules, which let us split your code into separate files and import what you need. Both projects use type module in the script tag, and skillswap also use it as in package.json on the server side. So let me show you this one function from skillswap's API file, because it uses almost every ESX feature in one place. So we have the export. So the other files, we can use this function. We have async and await for handling the fetch call without messy callback chains. We have a default parameter where params default to an empty object. We have a template literal with the backstick syntax to build the URL dynamically, and inside get headers we have an arrow function. These are not just fancy syntaxes, they make your code cleaner, shorter, and easier to read, and it's a good coding practice to follow this. Uh, okay, so now we are getting to DOM manipulation. So DOM manipulation is how JavaScript interacts with HTML on the page. The DOM is basically the browser's representation of your HTML as a tree of objects that JavaScript can read and modify. In SkillSwap, I built entire user interface using DOM manipulation. No React frameworks, no React, no framework, or anything else. Just pure plain vanilla JavaScript. Uh, so, mm, yep. So here is how I create a postcard. I call document.create.element, um, and to make a new article element, then I set its inner HTML using a template literal that plugs in the post data like category, skills offered, and skills wanted. Then this card appends to the page. Every single card you see on the skillswap homepage was created this way. JavaScript builds them on one by one and adds them to the grid. So another part is debouncing. So when a user types anything in search box, we don't want to fire an API call on every single keystroke. That would be wasteful, and it would waste um, much more resources as we scale. So instead, we use this debounce pattern. Every time the user types, we clear the previous timer and start a new one. The API call only fires after the user stops typing for 300 milliseconds. This is a small thing, but it makes the app feel smooth and reduces any unnecessary server overload. Okay, so now I want to show you something I built that was not part of the course material. This is my creative contribution. So, if you look at the background of my personal homepage, you would be able to see the stars slowly rotating, and this is all done by the Canvas API. And I think it's deployed on my other personal project. Yeah, so I'm talking about those starry background. Okay, coming back to this. So this is all done with HTML and Canvas API and JavaScript. So let me walk you through how it works. I have a star class where each star is its own object. Every star has a distance from the center of the screen and an angle and a speed. When I create 800 of these stars, they each get random values, so they all look different. The draw method uses trigonometry. Um, the draw method, yeah, it uses trigonometry dot method, math dot cos and math dot sign to convert the angle and distance into x and y coordinates on the screen. Then I use the canvas arc method to draw a small circle at that position. The magic happens in the animate function. Every frame I clear the entire canvas, update every star's position slightly, and redraw them all, and then call request animation frame, which tells the browser to run this function again on the next frame. This gives us a smooth 60 frames per second animation. I built this because I wanted my portfolio to feel alive and not just a static page. It was a fun way to learn Canvas API on my own, and also it gives much more depth to the background. Okay, uh, now let's move on to the backend. So Node.js is what let us run JavaScript on a server. Before Node, if you knew JavaScript, you could only use it in the browser. Node changed that. So Express is a framework that makes building web servers straightforward. And let me show you the entire setup for the skills web. Um, First, we create the app with Express, then we set up the middleware chain. This is important because the middleware runs in order on every single request. First, course, we have course over here, which allows our front end to talk to the server, then express.json, which makes the raw JSON form and with a request body and turns it into JavaScript object when we use it. Then we have express.static, which uh, which serves our HTML, CSS, and JavaScript files from the public folder. After middleware, we mount all the files. Any request to APIs slash API slash auth goes to auth root files. Any request to slash API slash post goes to the post route files. This keeps our code organized instead of having hundreds of routes in one file. Okay, so here we have MongoDB. MongoDB is a database. It's a NoSQL database, which means instead of tables with rows and columns like SQL, it stores document that looks like JSON objects. We are using the native MongoDB driver instead of any ORM like Mongoose. This gives us more direct control over our queries. So here is our connection pattern. We use a singleton, which means we connect the database. Um, which means we connect the database once and then reuse the connection for every request. Uh, then if the DB returns DB line checks if we already have a connection. If we do, we just return it. No need to connect again. And then here is an example of how of building a search query dynamically. when a user search something, we create a regex filter that checks the skill offered, skill wanted, and the description fields. The dollar options I flag makes it case sensitive, so searching like a Python with a small p or Python with a capital P gives the same result. And now we have authentication. Authentication is how we know who is making a request. We use JWT, which stands for JSON Web Token. The flow is simple. When you sign in or when you sign up or log in, the server creates a token. The token is a signed string that contains your user ID, name, email. The front end stores this token in local storage and sends it with every request in authorization header. So here is the auth middleware. It's only about like approx 12 lines, but it protects every route that needs it. It grabs the authorization header, checks that it starts with the bearer, extracts the tokens and verifies it with JWT verify, and then attaches the decoded users info to the request.user. Now every route handler that returns this middleware knows exactly who is making the request. If the token is missing or invalid, the middleware sends back a 401 error and the route handler never runs it. So you can see the full flow over here. User logs in, gets a JWT token, sends it with every request. Server verifies it and allows access to it. So it is simple, but it is pretty effective. So now just quickly on tooling and deployment, we use ESLint to catch bugs and enforce coding rules, and Prettier to auto format our code. For deployment, I use two different platforms. Like my personal homepage was on GitHub Pages, and Skill Swap was on Versal because it needs to run on backend server. The config is just two routing rules. If the request starts with API, send it to our Express serverless function. Everything else gets served as a static file from the public folder. Two rules, and our full stack app is live on the internet. Alright, so I think that covers all the concepts at a high level. Now I think I could go deep on one of them. So for the deep dive, I wanted to focus on REST API and how data flows through a full stack application. I chose this because the REST API is what ties the front end and the back end together. If you understand, if you understand this, you understand how how modern web app works, or like most of any of the apps here. So I mentioned REST briefly during the concept map, but let me explain it properly now. So REST stands for representational state transfer. It is a set of conventions for building APIs. The core idea is that your server exposes resources like post or users, and clients interact with those resources using standard HTTP methods. Get means give me this data, post means create something new, put means update this thing, and delete means remove this thing. Okay, so the server always responds with a status code and usually some JSON data. That is REST. It is not a library or a tool. It is just a pattern for how the front end and back end agrees to communicate. So here are the main endpoints for the here are the main endpoints in SkillSwap. So which was my second project, and notice how some requires authentication and some don't, and some even requires the owner, like for you to be the owner of the post. Okay, so oh yeah, I actually forgot to mention, but on a quick note, on status codes, 200 means everything is fine, 201 means something was created successfully, 400 means the client sent a bad data, and 401 means you're not logged in. 403, I think it means you're logged in but you don't have the permission to do anything. And 404 means the thing that you're looking for does not exist, and 500 means something went wrong on the server side. Okay, so now I'm gonna trace through this. So let us start with the simplest flow. A user a user comes to the skill swap and types Python in the search box, in the search bar. So yeah, so he comes over here, he searches something like Python in the search box, and then once that's done, on the front end, the first thing that happens is the debounce we talked about earlier. The app waits like 300 milliseconds to make sure the user has stopped typing. Then it calls the fetch post, with the search term. Then in the API.js file, the fetch post builds a URL using URL search parameters. This turns a JavaScript object into a proper query string. So the final URL becomes slash API slash post with question mark search equals Python. Then it sends a get request with the fetch function. So now the request hits our Express server. Express passes the query parameter, and they are available as request.query.search, request.query.category, and request.query.sort. So the route handler builds a MongoDB filter object dynamically. If there was a search term, it creates a regex filter that checks the three fields like skill offered, skill wanted, and description. The $or operator means it matches. If any of these fields contains the term, the dollar option I make is in case insensitive. So, like I said before, Python with a small p or the capital P would give you the same result. Then we call MongoDB's find method with this filter and sort, and MongoDB does its thing and returns an array of matching post documents. Back on the front end, JSON response come back. JavaScript looks through the array, and for each post, it calls create postcard to build a DOM element and append it to the grid. So to recap all of this, the user types, debounce waits, fetch sends a get request with a query parameter, Express passes them and builds a MongoDB query. MongoDB returns the results, and JavaScript renders them as cards. All of that happens in about 200 to 300 milliseconds. Okay. Now let us look at a post request. The user is logged in and wants to create a new skill exchange post. So on the UI, it will look like, oh, I have to log in for that, but it's fine. So they fill out a form with the skills they offer, the skill they want to learn, a category, and description. When they click save, the app collects all those forms values into JavaScript object. Then it calls create post, which sends a post request to API to slash API slash post. And notice two important things in the header. First, it checks the content type is set to application slash JSON, so the server knows the body is JSON. Second, there is an authorization header with bearer followed by the JWT token. This is how the server knows who is making the request. The body contains the form data converted to a JSON string with JSON.stringify. Now the request hits the server and goes through the middleware chain in order. First, express.json passes the JSON body and puts it in the request.body. Then the request hits the post route. The route has auth middleware as second argument. That means before the route handler runs the auth, and the middleware checks the JWT token. If the token is valid, attaches the user info to request.user and calls next to continue. If the token is invalid, it sends back a 401 error, and the route handler never runs. Once we are past the authentication, the route handler checks all the required fields are present. Then it builds a post document that includes user's ID, name, and request.user. It calls insert1 to save it to MongoDB, and MongoDB returns the insert ID. The server sends back a do1 status with the new post as JSON. On the front end, model closes and the home page refreshes to show the new post. For the last flow is sending an inquiry. So this is the most interesting part because it involves two collections and shows the difference between authentication and authorization. So a user is looking at someone else's post and wants to reach out. They write a message and click send. On the server, three things happen before the inquiry is saved. First, the auth middleware runs. Then this is authentication. It answers the question, who are you? Then the route handler checks if the post actually exists with find one. If it doesn't, it's gonna give you like 404 error. Then it checks if the user is trying to inquire on their own post. It compares post.user id with request user id. If they match, it sends back an error 400 that says cannot inquire on your own post. This is the authorization. Authentication asks you who are you. Authorization asks you are you allowed to do this or not. You can be logged in and still not be allowed to perform certain actions. Once those checks pass, the server inserts the inquiry document into the inquiries collection, but it also does something else. It updates the original post with $include inquiry count 1. The $inc operator atomically increases the count by 1 automatically means even if two people send an inquiry at the exact same millisecond, the count will still be correct because MongoDB handles the increment at database level. And when an inquiry is deleted, we do the reverse. The $inquiry count negative 1 to decremented. Okay. So all the three flows follow the same fundamental pattern. A user does something on the page, JavaScript sends a fetch request using one of those request methods we talked about, get, post, put, or delete. Express receives it and runs it through the middleware. The route handler talks to MongoDB. MongoDB sends back the data. Express sends a JSON response, and JavaScript updates it. The beautiful thing about REST is that the front end and the back end are completely separate. You could rip out all the vanilla JavaScript and replace it with React, and API would not change at all. You could also swap MongoDB for Postgres, SQL, and all the front end would never know. The decoupling is what makes REST so powerful, and why is it the standard for building web applications. Okay, all right. Let me show you something in action with some live coding. Let me switch to my VS Code. Yep. So here we are in my skill swap folder. So here we are in my skill swap folder. For the live coding, I'm gonna add a brand new endpoint to skill swap. Right now we are going to build a stats endpoint that tells us how many posts exist in each category. This will get a request following the same REST pattern we talked about. um, so here we have our post request. I'm sorry, here we have a get request. So get all post routes. This one will give you get all posts, and this will give you by the ID. So I need to add my new route between these two, and you may ask why between them, why not above both of them or below both of them. So it's because Express matches routes from top to bottom. If I put my route after the ID route, Express would see a request to slash API slash, oh, so basically we'll see a slash API slash post slash stats, and it would basically think like this would need an ID, and it would try to find the post with that ID and it would fail. So order does matter over here. Okay, so let's begin. So let's start by router dot get the autofill. Okay, not gonna use it. Then let's name it as stats, and yep, we are gonna need a sync. And so I'm defining a new get endpoint here. When someone sends a get request, it should go to the slash stats. Okay, this looks good. And then we are gonna use a try block. Now inside the try block, because we are basically using it so we could catch any errors if they occur. So let's grab everything from the database using const db equals to await connect db. Yeah, that looks correct. And then we are using this singleton pattern that we talked before over here, so we could reuse the connection again and again. Now let's make const stats equals await db dot collection. Db dot collection post. Yeah, that looks good. So and now here, instead of like a regular find query, I'm gonna use MongoDB's aggregation pipeline. Think of it like an assembly line for your data. The data passes through each stage and gets transformed along the way. So what I'm gonna write is this almost looks correct. Yeah, I think this looks correct. Oh wait, it's gonna fill the whole thing. But I only need group underscore id, and here I would need to sort it by the category. So I'm gonna write category and then count, and we're gonna count that looks correct. And then so if anything I should explain. Oh wait, this thing is so annoying. So the dollar sign before the category means I'm referencing the actual field value in the document, and for each group count how many documents are in it by summing 1 for each. Then I should write I should also write a sort function so that we could see which document has the highest, which category has the highest documents. So yeah, that looks correct. And oh wait, what? And then after that we are gonna make it to array to basically convert our results into regular JavaScript array. And then we are gonna use result or response JSON. That looks correct. So by this we are sending back sending it back as a JSON, which is a standard REST response. And then we are gonna have the standard error handling. We are using catch, and that looks correct. And let me save this server, and then let me go to the browser now. And here if I low slash API slash post slash stats, and there we go, we can see our category with the count, and we can see music has the most, then whatever comes next. These number comes from our seed script, which randomly distributed about 1050 posts across the 7 categories. So that is about the 10 lines of code to add a completely new endpoint. This follows the exact same REST pattern we traced in the deep dive. A get request comes in, Express routes it to a handler, MongoDB does the work with the aggregation pipeline, JSON goes back. If we wanted to take this further, I could have written a fetch call on the front end to hit the endpoint and render the stats as a chart or dashboard, but because of the time constraints, like this is what we did, and the API is already ready to go. Okay, so alright, to wrap The sub we started from static HTML page, added interactive JavaScript and DOM manipulation. We talked about building a server with Node and Express and connecting it to MongoDB, securing the JWT token, and deploying everything on Vercel. GitHub pages for static site and Vercel for full stack apps. Along the way, I showed you a creative canvas animation I built on my own, which was a fun way to push beyond what we learned in class. And I really hope this video helped you understand how all these web development pieces fit together and how REST APIs act as central hub to connect everything. And thank you for watching.